So in this video, we are going to work through the simple quadrilaterals and triangles cheat sheet. All of this comes from our Envision book, but I am going to break it down into a simpler table that you can kind of cross-reference because sometimes formulas and details are a little bit difficult. Now, the first thing we're going to do before we start any of these columns, which I am going to go column by column, is I want to go down to the bottom where it says draw a picture. And I would like to draw these because as we do this, I do want to show you where we're getting the information from and what that looks like. So the first thing we're working with is a rectangle. And while yes, we've discussed in class that squares are in fact rectangles, but rectangles are not squares, we're going to draw it like a traditional rectangle, showing the differences in the sides. So when we draw this picture, just for the sake of space, I'm going to make it wider than it is tall. We're not going to put measurements to it. We're just going to draw the picture like that. And then our square, we are going to draw as equally as possible, 4 sides, making them equal. So here's the definitions. So a rectangle is a parallelogram, but it has a requirement of having right angles in the corners. So the parallelogram has to have 2 sets of parallel sides, but it does not require there to be right angles. What it does need is these 2 sides to be the same length and these 2 sides to be the same length. Similarly, these 2 sides are the same length, while these 2 sides are also the same length. With a square, obviously, we have our right angles all the way around, but all 4 sides are equal. So this is kind of what they look like. We've got rectangles and parallelograms as they're shown are very similar in that they don't have all 4 sides equal like a square does, but the difference is that the rectangle requires those 90-degree angles in the corner, those right angles as we call them. Same with square. It has the 90-degree angles just like the rectangle, but all of the sides are equal. That's why we put the single mark. Those are the traditional markings for showing that the length of those sides are the same. So that would say that these 2 are the same, these 2 are the same, these 2 lengths are the same, these 2 lengths are the same, and then all 4 of these are the same. Now, that is for, trying to keep it straight, rectangle, parallelogram, square. Now, rhombus is a little bit confusing because we don't use that term as much, but it is taking the idea of a square and tilting it just like the parallelogram. It does not require it to have right angles, but it does still require it to have the equal sides. I didn't get that quite right. I'm just doing my best to make it look as equivalent as possible. So all 4 sides are still the same. Now, with that said, a common name for this, if we were to turn it upright, let's see if I can draw this appropriately, because sometimes it's a little bit more difficult, is a diamond. All right. If you tilt it like this, it makes the diamond shape. But traditionally, we look at it with the base here and, the height going up. So that is what a rhombus looks like. I'm doing both just so that you can see the traditional way of looking at them. All right. All right. And then a triangle is pretty obvious. Now we have a couple different types of triangle. You can have your equilateral triangle where all 3 sides and all 3 angles are the same. Okay. You can have an obtuse triangle, right? We could do an acute triangle where this is a small side. You can do a right triangle, which is traditionally what we're going to be working with in a lot of cases, because we are going to be working with a lot of rectangular shapes. So we have a lot of different triangles, but the biggest key mark on this is that it has 3 sides, whereas parallelograms, which all of these are technically parallelograms because they have 2 sets of parallel sides, that is the marker for all of these. They're just different categories of parallelograms or quadrilaterals, which have 4 sides. These are what we're going to be working with, and we're going to be answering the questions as we go through. So the pictures are going to help us really define that. Now, we can look at all 4 of these and automatically say, you know what? All 4 of those have 4 sides. So when we fill this in, it's 4 sides, 4 sides, 4 sides, and 4 sides. And all the triangles, keyword there being tri, like tricycle, you have 3 wheels. Tri is the indicator for 3. Okay, so just giving you a little bit of vocab understanding. On these next ones, we've already kind of talked about them all being parallelograms, meaning that they have to have 2 sets of parallel sides through these. And that stands to reason here. So you have 2 sets here, 2 sets here, 2 sets here, 2 sets here. But triangles, because they don't have equal number of pairs, they don't have any set of parallel sides. I'm going to put a line through it denoting that that's a 0. All right, guys. So far we have the number of sides, how many pairs of sides are parallel. Now, the number of congruent sides, those are the sides that are of equal length. Okay, so these 2 are congruent. It's kind of a new word. Okay, congruent meaning the same length. Okay, so in this case, we have this pair here and we have this pair here. So there are 2 pairs of congruent sides for a rectangle. Same thing here, 2 pairs. Remember, when they have the same number of lines, that means they're the same length. So these 2 and these 2 and these 2 versus these 2, depending on which one you're looking at. Now, excuse me, squares and rhombuses, because they require our 4 sides, we have 4 congruent sides. It's not in pairs, it is all 4 sides. Okay? So everything's equal in this case. Now, when we're talking about triangles, this is really dependent on it. We can have congruent sides. If you have an equilateral, all 3 of them are. If you have a 90-degree angle here, these 2 are going to be the same. So the way this is going to look, well, let me rephrase. These 2 can be the same. There is instances where one might be longer than the other. Now, if we draw that same triangle, and I'm going to try and make it the same shaping, you're 90 degree, and you have this, then this one has a pair there. This one has all 3. So this one is dependent on the type of triangle. So as you can see, this one has 3, this one has 2, but say these are all 3 different lengths here. Maybe it's a 30, 60, 90 triangle. You'll talk about those later and it'll make sense. But it really has to have the markings. These are very key into telling, are they the same? Okay? So try not to lose too much of my spacing here. Right angles, yes or no? So this is just a yes or no. So if we have a rectangle that has our 90-degree markers, yes, a rectangle must have 90-degree corners. That's a requirement of the shape. Okay, these are all the things that tell us where they fall in these categories. Because these are the categories of quadrilaterals. By the way, in case I didn't say this already, quadrilaterals, quad meaning 4. Meaning 4-sided figures. Now, these aren't all of them. You still have things like trapezoids, which we'll talk about later in the unit, but this is just part of it, okay? We're talking about a specific grouping of them right now, but quad meaning 4, while we already talked about triangle. I do know that one. Triangle means 3. So just kind of helping you out with some of those verbiage, some of those root words or root prefixes, if you will. Now, in a parallelogram, you can see there are no 90-degree markers because it is at a bit of a slant. So this is going to be a no. But a square, of course, has to have their 90-degree angles, so that's a yes. Diamonds, much like parallelograms, are the counterpart to squares, but it doesn't have those 90-degree angles. It also slants a little bit. And for the triangles, only for what we call right triangles, which is those triangles that have 90-degree angles, okay? Ran over a little bit there, but you can read that. So only for these ones. Now, not all right triangles have the same length sides. It's not like a rectangle or square in this. You could have it to where they're very different sides, different types of triangles, but if they have the markers here, they'll have similar sides, but they need to have that square in the corner that indicates that 90-degree or right triangle, all right? So perpendicular lines. So we know that parallel lines are ones that run like this, where they're side by side, correct? Those are the ones that run in the same direction, okay? Now, perpendicular lines, just to remind you what those are the ones that cross like a plus sign, like that, okay? Where they make those 90-degree angles that we keep talking about. So when they meet like that, they have a 90-degree angle. So if we see here and say, yes, there is a 90-degree angle, the answer for this one would still be yes, because our corners make that 90-degree, that perpendicular angle. Same thing with the square. Those have those same 90-degree corners. It's a requirement of the shape, as we've been saying, all right? Now, as we look at our two that do not have 90-degree angles, they lean. They're not going to have that perpendicular intersection at the corners. So the answer for these are no, right up there with does it have right angles? These should pair up in the same manner, okay? They're going to have, if they've got one, they've got the other. And again, this is only for right triangles. Oh, not a T. Let's try that again. Only for right triangles, okay? So only for these two guys right here, where they do have that 90-degree, where they've got and they're not always vertical, but we can say normally they're vertical, up and down, and horizontal, left to right. But we know when we're drawing them on a piece of paper, they can kind of move around, so sometimes they're not exactly like that. So let's go down here. Measurements that are used to find the area. So area, we have to remember, are going to be the sides that help us find the space between. So remember, perimeter is like a fence. That's the part that goes around. We're not talking about that. We're talking about I need to get new flooring for my house. I need to know how much area my kitchen is. That's all this space inside. So in most of these, a lot of times it is things like length and width or base and height, depending on how it looks. But let's talk about it specifically. So measurements to use area. The formula for this is area equals length times width. So the ones that, well, actually I should have written that down here. I apologize. I'll leave that there for now, but it's written like this. Area equals length times width. I apologize. But length and width being going this way, length being how far back it goes. It's like a depth almost, okay? Now for our second column with our parallelograms, these are titled a little differently because it does lean. It doesn't talk about it length and width because it's really not going, it's not really going a length. It's going kind of on a height because it's leaning. So I'm going to explain this as best I can. We've got a base, which would be this area here. This is your base. Okay. And then, height. And this is where it changes a little bit. So where this one has a length and a, well, I should say width and a length, okay? Do this. This right here is your width. And this right here, oh, I did that really bad. Sorry, guys. And this right here, if I can write it over here, is your length, okay? All right, that's that side piece. Base goes this way, but on this one, because it leans, these sides aren't straight up and down. So when we do these, we have to kind of get this to be a perpendicular right angle, okay? Make our triangle over here. But this right here, this dotted line, this is our height. The height must be vertical. And the reason I say that specifically that way is when you go to the doctor and they measure you for how tall you are, you're not leaning against the wall. You're standing up straight and tall. So you have to get a straight and tall. These are leaning. You can't use those. Okay? You have to use the base, which is just the bottom that's touching at the bottom. You're not going to go all the way to the end. And then you're going to use the height. Okay? Height being standing up in the middle. It's kind of where you have to make its own place, and it's usually going to give it to you, okay? The formula for this is very similar to your length and width, but it's going to be area equals base times height. Same principle, but this one you have to put in the height, kind of like superimposing or laying it on top of the shape, because it's not actually on the outside of the shape. Now, squares are easy. You're still doing a width kind of thing. Here we go. Let me get that right. This is still a width. And this is still technically a length. It looks just like a rectangle in its location. So you can say, oh, no, let's do it this way. It's going to be side length regardless, because all the sides are the same. But we still talk about, we could write this actually two ways. If this formula is more comfortable, technically this still works. But for squares, the formal is going to be the sides squared, okay? So it's side times side. This is kind of the more correct version for this, but technically this works too, okay? So I'd prefer you to use this one, but this one works just like this one. It's the same kind of measurements. If it's easier to just keep the same thing in mind for completion purposes, okay? So just like this and this are similar, like these two are very similar and these two are very similar. The only differences between these and these is these two have the same length sides, these do not. So we're still going to use base and height for the rhombus. Remember, this is the name of the rhombus. This is the name of the parallelogram. They have the same formula, the same details, and they work very, very similarly, okay? So you're still going to have to superimpose that invisible thing with the right angle to get your height. So again, that dotted line is your height. All right. And this base piece right here is across the bottom, okay? So your formula is once again going to be area equals base height for that rhombus, okay? Rhombus being that diamond-y style shape, okay? And there's what the word looks like again. It's kind of a fun one. Kind of reminds us of the word rhyme with that RH at the beginning, if that helps you remember the spelling, okay? Now, triangles are going to be a little more difficult because they're not always going to be obvious like a right triangle, but we can, with these, still find a height, right? So there's the height, there's the base. This one we'd have to tilt a little bit. This one we'd have to do a height down the center, much like we had over here. We've got to create a right triangle, no matter what kind of triangle it is. But the formulas, rephrase. So you're going to have the base. Let's not get ahead of ourselves. The base is going to be the part at the bottom. So here is the base here, this part right here, part here, here, here. And if we're being technical here, there's our, we made our right triangle inside, and this whole thing would be your base, okay? Now it's base and height, and the only ones that the height actually are on the outside are when we have right triangles, which those are super simple. The other ones are going to have to give you the height, at least for now. There will come a time where you could find the heights later, but that is not for this year. I don't want you to stress. Any of these weirder ones, I say weirder loosely, the ones that are not right triangles, the height will be provided, okay? And the formula, there's two ways that it can be written. So it can be area of a triangle equals 1/2 times base times height, or area equals base height divided by 2. Me personally, I like the second one. This is the one that we went over in class the other day. I don't mind doing the fractions either. These are the same thing, because remember, if you go over here, and I'll show you real quick, so you do 1/2 base and height. Remember, these are considered whole numbers. You put them over 1. Really, it's 1 times base times height, which ends up turning into this, okay? But I just like to go straight here. To me, it's easier unless I have to work with fractions, which doesn't happen very often. So, I'm going to screenshot out a little bit. I just want you to see the whole page, how it should look. Now, please, 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 if you've skipped to the end and you're just like, oh, I'll just pause it and fill it out, I really want you to go back and listen to the full walkthrough about the reasoning behind it, because you're going to remember it better if you have that reasoning. So here is the full worksheet. I'm also going to put a scan in after everybody's turned their papers in. Remember, these are due when you come into class on Friday. When I return, I will grade them over the weekend. This is your practice grade for week 1. All right. And again, this comes all out of our Envision textbook. It is just putting it on a faster reference page for you. Don't worry about the back of the page yet, because I will get to that later. But for today, I just want you to really focus on understanding this material. When you're done, I will also put a note in Schoology about what IXLs relate to these. Some of y'all have already started them. If you get them to 80, go ahead and go to 100. The better mastery you get, the better you're going to do, okay? I hope y'all are having a great day, and I will see you when I return.